Hello, Algebra students. All right, we are going to work through the extra credit today. I suggest you watch closely as we will be reviewing everything needed for the test. In addition, I will be unveiling my favorite game. I will be unveiling one of my favorite pastimes. And I will also be unveiling a brand new color of pen. Yeah, I'm pretty excited about that. You guys know me with my pens. All right, so here we go. So we need to do a prime factorization of 36. I'll start right off with my brand new color, green. I had this green before. I had the purple, and I had the pink, and I had the blue. Now I get to add the green. Yay! Prime is the key word here, folks. Prime. You can only take out prime numbers. So we're going to set up that upside down ladder. And remember, prime numbers, some of you were asking me on the last quiz, it's a number that you can only divide by two numbers, 1 and itself. Okay, so 7 is a prime number. You can only divide it by 7 and 1. 10 is not a prime number because you can divide it by 1 and 10 and 2 and 5. There's more. So 36, got to think of something that is a prime, and that's always start with 2 and then try 3 is also a prime and work your way up. So 2 goes into 36. If you're not sure, you can go off to the side and divide it, but it is 18. It's even still, so I can do another 2. Again, making sure these are prime. I get 9. That is not even anymore, so I cannot do 2. But I'm going to think and then go, oh, that's right, but I can take a 3 out, and 3 is also prime. I get 3. And then lastly, I can take a 3 out, and finally you'll be left with the 1 at the bottom. That's when you know you're done. And this over here is your prime factorization, and they're all multiplied all the time. So it's 2 to the 2 times 3 to the 2. Or if you wrote this, I wouldn't say it's wrong, for sure. So we can do that right there. All right, we're going to jump to GCF now of 2 numbers. This again was a prime factorization. So I'm just taking a number. I'm trying to figure out how I could write it out such that this number and this number are prime numbers. Okay, so if I had 2 to the second times 9, because I stopped here for something, that would not work because 9 is not a prime. Now when I get down here to GCF, it does not have to be prime anymore. If it needs to be prime, it's going to say prime. So GCF is just the biggest number you can divide both of them by. And I gave you an upside down ladder technique to use as well. So we can set up both of them next door to each other here, 40 and 70, and upside down. Now you can take a prime number out, but it's going to take you longer to work through this. So you want to try to think of the biggest number you can think of. And let's say, okay, I can only think of a 2. You actually could take a 7. Do you see the 7? I'm going to assume you don't. Let's do the 2. So 42 divided by 2 is 21, and 70 divided by 2 is 35. So again, you have to look at those, and you need to know those multiplication facts. That's why it's important to have all that down, because then it's number recognition. So if you've not done past your fluency reflex yet, you really need to work on that so you can round that out before you leave St. Peter's here. So 21 and 35. The factors of both of those is 7. 21 divided by 7 is 3. 35 divided by 7 is 5. 3 and 5. Anything we can take out? No. So the answer to this question is over here, and we multiply it. So 2 times 7. So the GCF is equal to 14. You need to be really clear on the text and box your answers so that I can find, you can do this. That's great. You'll get partial credit if this is all right. But this is the answer. So I need to know that you know how to use this to get the answer. Now the next one is the same, except that what does it introduce here? Letters. So if you're not sure, 30x squared and 45x to the fifth, you can do the numbers first. So like 30 and 45, what can you take out of that? We can take a 5 out, and then how many of these x's can you take out? You take the lowest number, lowest power, so it's 2. So what do you have left if you take a 5x to the 2 out? You have a 6, and you have a 9x to the third. Remember, when you divide that out, you're actually subtracting the powers. So the x's are handled, but look at the 6 and the 9. I can still take a number out, can't we? Take a 3 out. If I divide that by 3, I get 2. If I divide that by 3, I get 3, and then the x to the 3 is still there. Anything here? No. So here's my answer. My GCF is 15. I just multiply the two numbers. The x to the second just trails along. Now some of you might have been able to see the x part just fine, and maybe you only did this whole thing with just the 30 and the 45. That's fine. You just needed to find out the 15. And maybe some of you could see it without doing the ladder. That is also fine. That's the goal here. Same thing here. If you see the biggest number, you can just tell me it. I'm happy if you can see that. That's what I want you to get a good number sense. Down here, we have Mrs. Mendoza is organizing seating for a standardized test. 45 ninth grade students, 120 10th grade will take the test. Each row will have the same number of students, but 9th graders and 10th graders will not be seated in the same row. If she puts the greatest possible number of students in each row, how many rows will there be? So this is the one where you're going to take the two different numbers and do the GCF. So we got, this is the, which one? 9th graders here. And this is the 10th graders. Just to kind of keep it separate, it doesn't really matter at this point. But we are going to now look for a factor. You can see 5 goes into that. So 5 goes into 45 9 times. 5 goes into 120. Oh, how many times does that go in, class? If you're not sure, go off to the side. 2, 10, 2, 0, 4. 24. Okay, then I got 9 and 24. Oh, I can divide them both by 3, right? So 3 goes in there, 3 goes into there, 8. Okay, so this again was my 9th, this was my 10th. So I'm going to have 3 rows of 9th graders and 8 rows of 10th graders. So all you have to do is add those two, and we're going to have a total of 11 rows. The number of students in each row will be 5 times 3, which is 15, but that's not what the question asks. The question says how many rows. And so there's going to be 3 9th grade rows and 8 10th grade rows, and you're going to end up with 11 rows. And each row is going to have 15 students in them. So it's kind of cool. Now we're moving on to factoring. That's the majority of the test here is factoring. And I did put these all down right here to kind of help the thing that's on the board in class. And when we're going to factor, your number one thing is to look for the terms. So you look at this and you say, how many terms? 2. Okay, so I got to check to see if we can factor, and I've always said the AO number one thing you try first is GCF. Every single problem. Just try it. GCF. Is there a greatest common factor? Yes, there is. I can see for sure a 10 because they both end in 0. And then 3 and 5, no. But they also each have at least one y, right? This is the y to the first. So I can take a 10y out. You put your parenthesis up because that's when you're factoring is going into parentheses. You're going to subtract because it's a subtraction there. Now if you take 30 divided by 10, you get 3. And y to the third divided by y is y to the second. Remember, you subtract the exponents. 50 divided by 10 is 5. And y to the 1, 1 minus 1 is 0. There's not a y term left. So before you wrap up and say you're done, look inside the parenthesis again. And there's nothing that you can take out of both of them. When we go on to this one, Again, look in the parentheses, n minus 3. Nope, nothing I can do there. N minus 3. Nope, nothing I can do there. But remember to view these as two big terms. So when you view them that way, you have an n minus 3 in both. So if we take out the n minus 3 out of both of these, what's left? N plus 8. That's part of the grouping. That was kind of how we introduced grouping, was it's like halfway done already, where we have this here. So you just pull that out and you're left with that. The true deal grouping now is here. And that's when there are 4 terms. 1, 2, 3, 4 terms. So the first step of grouping is, and it does tell you to do it by grouping, is to put parentheses around the first 2 and the second 2. If there is a subtraction sign in between, shove that with that whatever's here and just put a plus in the middle. You always want a plus in the middle. But you can't just take out the subtraction. Just push it with the value that's here and make it negative. Okay, that's my daughter's phone going off. Here we go. Looking in here, there's 2 terms. What's the GCF? Well, I can see there's the number, no, they got a number 1 here and a 5 here, so I can't take anything out of the number, but A's, we got 8 of the 3 and 8 of the 2. So I can at least take, and again, the smallest, 8 of the 2 out. If I take a 2 out, you subtract the exponents and get an A. Minus 5. If I took the 8 of the 2 out, you subtract the exponents and you get 8 of the 0, which is gone. Plus 2A and 10. Now in this case, it's the opposite of here. I don't have an A in both, so I can't take any A out, but I have a 2 and a 10. So I can take the 2 out front. And if I divide that by 2, I'm left with just the A. Minus 10 divided by 2 is 5. Yay! Look at what we have here, folks. We have an A minus 5 and an A minus 5, just like up here when we were practicing. So A minus 5 comes out, and when you take that out, what are you left with? A squared plus 2. So this problem up here was just kind of starting at this point and having you do this last step. And then this is the whole deal where you had to put in parentheses and actually get to that step. All right, let's review this one. When we look at it, we see that there are how many terms? 1, 2, 3. 3 terms. So our options here are these middle ones here. Of course, we always want to start with the GCF. So let's look and see if there's anything. These 2 have an X, but that one doesn't, so I can't take an X out. And the number 1, 10, 21, nope, nothing we can take out. So now we're going to look at the other options. And it's going to be a box 1, and the reason is right here. When there's a 1 in front of it, that means box 1. So let's go ahead and set up our box. What plus what equals 10? What times what equals 21? So you think about that, and if you're stuck, you just start doing factors of 21. So 1 and 21, you do them in pairs. 1 times 21. Add or subtract to give you 10? No. 2 doesn't work. 3 and 7. Does 3 plus 7 give you 10, or 7 minus 3 give you 10? Yeah, it does. 3 and 7, 3 and 7. They're both positive, both positive. So I'm done with that, and there's my answers. I just have to formulate them into my parentheses. So we have 2 parentheses. The first one is always the X in box 1, and then you look and put this in. And since they're both positive, it's going to be plus 3 and plus 7. Done. Okay, here we go again. There's 1, 2, 3 terms. The first spot is a 1. It's going to be box 1. What plus what equals a negative 3? What times what equals a negative 10? Actually, I mean to be writing up here the techniques we're using. We'll try box 1. You may be wondering, why is it not a perfect square trinomial? Because that's that bottom one here with 3 terms. And I guess I would be more triggered to check for it if I saw that that was a perfect square. But as soon as I see 21, I'm like, no, square root of 21 isn't a whole number, nor is square root of 10. And for that matter, nor is square root of 55. So that's not on my radar. And for the test, it will be in the order we learned it. So that's kind of a little bit of a clue for you as well. Because I know there's a lot of different techniques we're using here. So let's do this. We need two numbers that multiply. Let's see, we got 1 and 10. Can you add or subtract them and get 3? No. How about 2 and 5? Oh yeah, there's a combination of 3 there if I subtract them. So let's see, a 5 and a 2. And I got to figure out, one of them is going to have to be negative to give me this. But I need a negative up here. So it's going to be a negative 5 times 2. Negative 5 plus 2. Make sure you always check both levels to make sure it works. Because sometimes we accidentally do put the negative here and we got to switch it. All right, I'm done with that. I'm going to put those in. X minus 5 and x plus 2. All right, good. Move my little tabby tab down here so you can see it better. All right, let's try again. What? I'm going to use a different color. Let's do purple. What plus what equal... Oh, I jumped too quickly. 1, 2, 3 terms. First term is 1. I'm going to try box 1. What plus what equals 16, and what times what equals negative 55. All right, so we start with the multiples of 55, 1 and 55. Can I add or subtract those two numbers to get 16? No. 2 doesn't work. 3, no. 4, nope. 5 will work. 5 and what? 11. 5 and 11, and that's actually it. There aren't any other factors, but 5 and 11 will give you 16. So let's put 5 and 11 in. And it's got to be a positive 16, so that means these have to be positive. So how would that equal a negative? Is there any other way to get this to be a positive if these aren't? Well, only if one of them was 16 bigger, but there's no other choices. So when that happens, and on the test there's not going to be a long list. You know, I'll pick one where there's only a couple options for the box. And once you figure out that, no, I can't make that work. This one works, but this one does not work. So then we would just write can't factor, because you can't factor that. You just can't do it. And there is one like that. So be aware when you're working through those. I'll probably tell you what chunk they're on. But all right, it is halftime, and that means it's time to tell you my favorite game. My favorite game is, you ready for this? That's right. What else would I like than the game with all the numbers on it? Rummy Cube. If you have not played Rummy Cube, it is an absolute necessity. It is so much fun. All right, there you go. Now you know my favorite game. I will play Rummy Cube any time, any day. Unless I have a great math video to do, then I will not. All right, factor. Here we go. Let me get my little slip back here. I have how many terms? 1, 2, 3 terms. When I look through here for 3 terms, can I do box 1? No, because this is a 2. That means I could do box 2 or perfect square trinomial. Is the square root of 2 and 5, are they perfect squares? No, so I'm not even going to try that one. I'm going to try box 2 because of that. So we're going to say what plus what equals 7, and what times what equals, remember I multiply those two to get 10. All right, so can we think of some multiples of 10? 1 and 10. Can I add or subtract them to get 7? No. How about 2 and 5? Can I add or subtract them to get 7? And you betcha. So 2 and 5 works for this, works for that. We're good to go. Now the difference is with group 2, we start with a box, but then we move on and we do grouping. Okay, so what happens is, in order to do grouping, you need the 4 terms, correct? So I'm going to rewrite this, except that instead of the 7x, I'm going to replace it with these numbers here. Okay, so I'm going to cross these off so we don't mix those up. So I'm going to start with my first term, exactly the way it is, 2x squared. But instead of writing 7x, now I'm going to put 2x plus 5x. You got to make sure to put the x's in when you substitute here. 2x plus 5x. And then our last term here is plus 5. So do you see that 2x plus 5x is indeed 7x? So I'm just changing the way it looks depending on what I got here. Now I can put my parentheses in there. So we're going to go like that and that, that and that. Now we do the GCF. Okay, so 2x squared plus 2x, we can for sure take a 2 out and an x to the 1, right? The smallest x. So if I divide that by 2x, I'm left with an x. If I divide that by 2x, I'm left with a 1. That's not a 0. 2x divided by 2x is 1. Plus, I can take out a 5, but they don't both have an x, so I can't take out the x. 5 divided by the 5 gives you 1. Make sure you're careful with those. Now I look and see, oh, here's my 2 big terms, and there's an x plus 1 in both, so I take that out front. And once that's crossed off, I see what's left, and it's 2x plus 5. And you'll notice that the difference here is that this does have just an x, but this has a 2x. Whereas back on this side, all of these box 1s had xx and xx. That's why they're easier, because they're box 1s. When you end up with a number in front of it, that won't ever work to have an x and an x, because x times x should always be just x squared. So that's why you had to use box 2 on this one. I'll leave you plenty of space, but you do need to know how to do it. Now let's talk about determine whether the trinomial is a perfect square. Okay, so remember there was 4 checks. You do 4 checks to do it, but now notice it does say if so factor it. Well, if you've done the 4 checks, you pretty much almost have your answer already, don't you? So let's try it. Square root of n squared is n. Square root of 25 is 5. So that's a perfect square. That's the first check. That's a perfect square. That's the second check. This is an addition sign. That's the third check. We have to multiply. We're doing the 4th check now. You multiply and then times it by 2, and you get 10n. You check to see, is that 10n the same as that? And you would say to me, no way, Jose, it is not the same. At that point, the 4th check that you just did failed. So you'd say, no, it is not a perfect square trinomial. Let's try another one. Check number 1, is that a perfect square? Yep, it's x. Is that a perfect square? Yep, 9. Is that a plus? Yep. This one's irrelevant because that one can change, but not the second one. It has to be plus. Multiply 9x, times it by 2, always 2. See, 2 there and 2 here. I get 18x. You're going to check? Yes. Doesn't matter that it's subtraction. You're just checking the middle term, and the answer is yes. Great. I had all 4 things checked. So it is a perfect square trinomial. So yes is for sure it is, and factor it. So we're almost there already. We have the x, we have the 9. We just have to take down whatever sign is here, and it happens to be a minus. Put parentheses and square. That's it. Because remember, that's the same as this. Okay, so either way would be fine. Good. Now we'll go up here to the difference, the final one we talked about here, number 6, the difference of two squares. There was 3 checks we did. So determine, well, first of all, notice the difference here. I want to show you something. This also said trinomial, so remember tri means how many terms? 3 terms, and we had that written on my little sheet here. But up here, notice it says binomial, so that means 2 terms. So right off the bat, if I gave you something without 2 terms, that would just be a no. But they both have 2 terms, so that part's fine. Now, 3 checks. Is that a perfect square? Yes, P. Is that a perfect square? No. Done with this. There's no more to do. Square root of 30 does not come out to be a whole number. Right? If I take my calculator and do square root of 3, which you don't have a calculator, but you should hopefully know it. I'm trying to make sure it's showing. If I do that, you get a long number like that. It's not like 36, where I do 36 and get 6. Those are perfect squares. All right, let's try another one. Is that a perfect square? Yes. Is that a perfect square? Yes. Square root of 100 is 10. And the third check is difference. Difference means subtraction, not addition. So be very careful. Is that a subtraction? Yes. Fantastic. So the answer is yes, it is. If so, factor it. So this is the one, whereas down here, you had 2 and they have the same sign, and it's dependent on what is right there. It's a subtraction. If it was an addition, these would both be addition. But in the difference of 2 squares, you get 1 of each. So you're going to get an x plus the 10 using these numbers right here, the x and the 10, and an x minus 10. All right, it is time for our last break, and then my favorite pastime is, you ready for this? Dun, 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 dun. Puzzles. I love puzzles. I got this puzzle, Northern Wisconsin, last summer. I saw it and I was like, I want that puzzle. So my daughter snuck and gave it to me for Christmas, and it is still unopened because I just never find time. But I do love doing puzzles. Okay, there you go. Now you know my favorite game. I do like to read too, which I also never make time for. But anywho, last 2 problems and we're all done. Tell whether this times this is completely factored. If not, factor it. Okay, so I've got 2 parentheses. So your job right here is to look into each one and analyze it. 8x minus 5. Is there anything I could take out of that? I'm actually going to rewrite it right here. The answer is no. There's nothing I can do to that. Okay, so far there's nothing to factor, but let's look in here. How about in here? Is there anything I can factor? Yes, I can divide them both by 4. So if I take a 4 out front, notice I just kind of smashed it all together because it's all multiplied in between these parentheses here. If I take a 4 out of here and divide a 4 out, I'm left with an x plus 3. This is not the same as these. There was a plus in here. Okay, so don't think we're doing grouping. We're not doing grouping. We're just taking a 4 out of here, and now I'm left with 8x minus 5 times 4 times x plus 3. So whenever you have things multiplied together, I can put them in any order. So I'm going to move that 4 in the front and write it exactly the same, but with the 4 in the front. That would be 100% correct if you wrote it, but I would like to see you go that extra step and get it in the front. Last one, factor it completely. That's the key word to tell you that there's something more to do than probably what you start with. As always, and I should have written this up here, you always want to start with that GCF and checking. So when we get to this one, I notice 1, 2, 3 terms. So there's lots of options. Get the sheet down here. There's lots of options for 3 terms. But as always, I'm going to start with GCF. So when I look through these 3 and I just look at the numbers, 4, 30, and 16, I'm like, oh, 4 goes into 16, but does 4 go into 30? No. The only thing you can take out of all 3 of these is a 2. Now let's look at this. X to the 5th, X to the 4th, X to the 3rd. Okay, they all have an X. And what's the lowest power? X to the 3rd. Put your parentheses up. I still should have 3 terms in here. If I have 3 here, I have 3 here as well. So 4x to the 5th divided by 2x to the 3rd. Let's do the number first. 4 divided by 2 is 2. X to the 5th divided by x to the 3rd, you subtract them, the exponents. Next, minus, because it's a minus. 30 divided by 2 is 15. X to the 4th divided by x to the 3rd, subtract the exponents. Minus, because it's a minus right here. 16 divided by 2 is 8. X to the 3rd divided by x to the 3rd is 1. It's gone. So I can say, okay, good, I'm done. Except that, oh, I got that completely word, and that probably means there's more to do. So you use GCF right here. But now we're going to look inside again the parentheses. What's on its own out here is irrelevant right now. But again, I don't want to forget about it. So I'm going to highlight it. So at the end of the problem, I don't forget that it's there. All right, now I've got 1, 2, 3 terms. Okay, so let's look in here. Could we do perfect square trinomial? Is 2 or 8, 2 and 8 perfect squares? I mean, the x is, but the 2 and the 8? No. So is it box 1? No, got the 2 in front. So we're going to have to do box 2. So let's set up our box. What plus what equals negative 15, and what times what equals negative 16? All right, so what times what? Let's try them. So we have 1 and 16. Oh, that could work right away. 1 times 16. Let's see if we can get that to work. I need to get a negative, so one of these has to be negative, and I got to get a negative. Okay, so it's probably the 16. Let's just double check. 1 times negative 16 is negative 16, yes. 1 plus a negative 16 is a negative 15. And we won. We got it. Cross this off so you don't use that accidentally. And remember, we're going to rewrite the first term right here. Now, instead of writing this, I'm using these two. So, plus 1x minus 16x minus 8. Okay, we got to group them. So we're going to put parentheses around the first two, and oh, it's that subtraction I was talking about. Remember I said push it, do a plus minus there, push it with the 16 so that I can keep it inside and have that plus in between. So I can take out an x. Now FYI, if you guys put this negative first, you wouldn't have to deal with the negative here, because that would have been a plus 1. So that would have worked as well. Either way you put these in, doesn't matter. X times 2x plus 1. Because the 2 is still inside, but I took 1x out. I took the x out, so I'm left with 1. Now I've got a negative. When there's a negative in front, you want to take it out. So I'm going to take out a negative 8. So that leaves me with a 2x, and then negative 8 divided by negative 8 is a plus 1. Yay! Look what we got, guys. Just like we wanted. 2x plus 1 times x plus a negative 8, or just x minus 8, either one. And it's a good thing I highlighted that because I almost just forgot it when I looked up and I'm like, nope, that needs to come down here. 2x to the third and launch itself right in front. That's all she wrote. All right, feel free. Go back if there's a certain type that is still confusing you. You have them all right here now, every single type. So you can do that. Also, there's the practice A packet in the back of your binder. You could certainly do some of those on whichever section is still giving you trouble. And remember that what's on this post-it which is on the board, you will have to use. I'm not going to be erasing that. Otherwise, you should be all set to go. All right, take care.